Hello everyone, welcome you all to this video. Here we will cover few problems regarding this chapter of countability. As you can see that I have a list of problems, around 7 to 8 problems now I have in this video, and let's try to solve and let's see how much we can solve in this video. But I can promise that you will get some suitable tricks and techniques, as well as a few logical approach will be there that will be helpful to you to solve the question of countability areas asked in NET or GATE exam. Fine. So let's start with the first question. It says that let xj equals to 0 1. This is a set xj 0 1 for j equals to 1 to 3 so on, and you have y it is the product of all these xj's. J runs from 1 to infinity, and they are claiming in the first option that y is countable, in the fourth option y is uncountable, second and third option are obviously second option is very trivial option. As we will proceed further you will get the flavor, and we'll also discuss about the third option. So first of all, check the cardinality of y. That will be your basic job to do here. That cardinality of y, it is cardinality of this product set, correct? So that is nothing but cardinality of all these xj's. J runs from 1 to infinity, correct? Fine. And what is the cardinality of xj? Look at, it is 2. So you have this multiplication of all these 2's. How many 2? Look at 2 multiplied 2 multiplied with 2. How many number of 2's are there? Obviously countably infinite number of 2's are there. That is, you have aleph naught times, this is the notation for aleph naught as we have discussed in the previous video. So you have basically 2 to the power aleph naught, and by the previous video you know that 2 to the power aleph naught, it is nothing but c, which is the cardinality of your r, correct? So basically you have the cardinality of y, it is equal with cardinality of r. That implies y is going to be equivalent with r, and we know that r is uncountable set, so y is uncountable. Clear? Fully logical approach is there. I think it is clear to you, no? Okay. Thus your first option, which is that countable set, it is false, and fourth one is correct. All right. Okay. Now you know that set of all real numbers, it is equivalent with any interval, whether it is open interval, closed interval, or semi-open, semi-closed, whatever. So it is also equivalent with 0 1. Just for your convenience you have 0 1 closed interval, so they are equivalent. That is, their cardinality will be same. Thus your second option is correct. Fine. Now what about the third option? For option C, you need to know a terminology that is called countable union. In our last video we have already described this. It is this union, n runs from 1 to infinity, j runs from 1 to n. So look at, basically whenever this sort of union is there for you, that is n runs from 1 2 3 4 up to infinity, that is countable union. So this part stands for the countable union, and I'm claiming you that this part is a countable set. How? Can you verify? Countable set, how? Because look at this product xj, j runs from 1 to n. If you consider the cardinality of this set, this is nothing but 2 to the power n. Verify and let me know in the comment section. just simple arithmetic, nothing special. So 2 to the power n basically a finite quantity. Thus this set inside this union, this one is countable set. So what you have basically countable union of all the countable sets. It is going to be what? Countable by the result discussed in the previous video. So this whole thing is going to be countable, but in the third option is given that this one is uncountable, so C is false. Your answer will be B and D. Fine. Okay, let's come to the second problem. Read it carefully. It is your second question. It says that for each j equals to 1, 2, 3 and so on, you have all aj be finite set containing at least two distinct elements, correct? Then which one or are going to be correct? So you have aj as a finite set containing at least two distinct elements. So you can consider that your aj contains, obviously a finite quantity will be there, contains say three number of elements. Okay, that is a1, a2, a3, a4, all these sets. It is not necessary that all the sets will have the same number of elements, but that is guaranteed that all of these sets are finite set and will contain at least two elements. Okay, fine. So I'm just assuming for the simple case that this set a1 contains 3, a2 contains 3, a3 contains 3. So all these sets contain the same number of elements. Okay, I'm just considering the simplest possible case. You can consider two elements, so no problem, or one set contain 2, another 3, another 4, whatever you want, but all these elements are going to be finite quantities as given in the question. So they are asking that what will be this set, is it countable or uncountable? Look at, you have the cardinality for aj. In fact, that assumption will not affect your result. How? Because cardinality of aj, whatever it will be greater than 2 or it will be equals to 2. So whatever the scenario, it will remain be finite. So your aj is nothing but a countable set, and this union is countable. So countable union of countable set, what it will be? Obviously countable. Fine. So nothing special, just a simple property. So first option is going to be true, fourth option false. All right. Okay, now I gave you the idea in the last question. Using that idea, you just try to show whether B is correct or not, and also verify for C. Okay, that will be your duty, and let me know in the comment section. I'm just leaving it because it is completely depending upon the understanding of previous question. So solve it. Now here I will solve fourth question. Okay, fourth question. I'm just giving you the hints how to solve this fourth question, because third one is very trivial type of question, and you just solve it and let me know in the comment section, and I will make another video if you find it hard. Okay, also let me know in that comment. that if you are not able to solve this third question, I will definitely provide the solution in the next video, because in upcoming video I will also solve few more problems regarding this chapter. So I'm just leaving this third as your exercise. Now how to solve this fourth problem? Look at, read it carefully, that it is given that MAB, that is MAB is nothing but collection of all these functions, that is f, such that f from A to B. Okay, all possible functions from A to B, this collection, it is basically denoted by MAB. And then they are asking the cardinality of which of the following is or are going to be equal with C. Fine. Have you any idea how to solve? You know, a very basic thing, that cardinality of a set. Suppose I'm considering MAB, just the same thing I'm considering. Cardinality of this, that is collection of all possible function from the set A to B, it is nothing but cardinality of B to the power cardinality of A. In the very first videos we have discussed the things, as you know. If you are following all the videos, then you know that we have discussed in the very preliminary videos that cardinality is going to be like cardinality of, suppose all possible functions we are considering from A to B, and if we consider the set of all possible functions from A to B, that is B to the power A, cardinality of B to the power cardinality of A. In fact, whole number of possible functions, that is. Okay, so just use this concept and you will get the solution, that M, first option, it is MZZ, that is F from Z to Z. How many possible functions are there? Obviously cardinality of Z to the power cardinality of Z. Cardinality of Z, you know, aleph naught, and it is to the power aleph naught, and what it will be, aleph naught to the power aleph naught. Just go to the previous video and let me know in the comment section what will be your answer. Correct? Just use the same procedure for each and every option B, C, D and E, and give me the answers. Fine. That is also I am leaving you for exercise, because these are very trivial, and depending upon just a few steps you will get the results. For that purpose, obviously you need to watch the previous videos as well. Now what about the fifth question? Read it carefully. It says that let X be a metric space and A subset of X be a connected subset with at least two distinct elements. Then the number of distinct elements in X is, what? Look at X be a metric space, so we can simply consider R along with the usual metric. Fine. This metric space we can consider R and D, where D is the usual metric. And look at A is a subset of this metric space, that is A is a subset of R, and you know that all the subsets of R in fact intervals, and be a connected subset with at least two distinct elements. Correct? So singleton set, it is not possible because it contains only one element. Phi is not possible. So only remaining things are like AB, closed interval AB, this sort of intervals are there, or semi-open, semi-closed intervals are there, or these things are there. Okay, so whatever will be the scenario, all these things or all these subsets contained more than two elements. In fact, infinite number of elements are there, so at least two distinct elements. So all the hypotheses have been satisfied by this choice. Fine. Then number of distinct elements in X is, what will be your answer? Number of distinct elements in X is 2, obviously false. More than 2 but finite, obviously false, because R contains uncountably many elements. In fact, uncountable number of elements are there. Countably finite, not the case. So fourth option is going to be the correct one. Fine. We have just taken a simplest case and able to solve this question. In fact, these sort of tricks are required. Otherwise, if you want to solve this question in manual way, then obviously you should have proper understanding of topology. Otherwise, you can tackle this sort of question like this way to solve in the exam hall. Now we are moving on to the sixth question. If you have any doubt, let me know in the comment. Now we are moving on to the sixth question. Sixth question says that let X be connected subset of R. If every element of X is rational, then cardinality of X is, that is again your job to solve it. I'm just giving you a help that X be a connected subset of R. What are the subsets of R? Phi, singleton set A, all the possible intervals. Okay, these are the subsets of A. In fact, they are giving that X, every element of X is rational number. So just think about it and solve it. If you are not able, also write it in the comment box, so that in the subsequent video I will provide the solution as well. Now come to the seventh problem. It is in fact very interesting question. Seventh problem. It says that which of the following are false? The set of all polynomials with integral coefficient is denumerable. The set of all polynomials with integral coefficient. So what actually it means? It means that the set of all polynomials. Suppose if you consider, say, constant polynomial, I'm considering P naught, where P naught A naught belonging from here, the coefficient from integral coefficient, so it is Z. P1, it is in fact A naught plus A1x, where A naught and A1 is belonging from Z, correct? Just follow and you will get the all flavors what are required for this question. Okay, fine. Thus you have, obviously here A1 should not be equal with 0, here A2 should not be equal with 0. This is the set of all polynomials having degree 2, this is having degree 1, this is for all constant polynomials. Similarly Pn, it will be A0, A1x, A2x square up to Anx to the power n, such that all this xi is belonging from Z, because the coefficients are from integral coefficient, from integer. Okay, and an not equals to 0. This is necessary condition. Fine. This is the, you can say, set of all polynomials or having degree n, and these coefficients are coming from Z. So in fact the set P is nothing but this union P, you can say K, where K runs from 1 to the set of all polynomials, so it is not restricted up to n, it will go like this way, correct? Fine. Now what you need to do is to find the cardinality of this P. In fact, cardinality, then what you have, or in other sense, just look at P naught, all the A naught are coming from natural number set. So the cardinality of P naught is going to be Alif not, correct. All the A0 and A1 coming from Z, so the coordinate of P1 is going to be alif naught cross alif naught, because how many possible choices are there for this A0 and for this A1? Alif naught times alif naught, so it is cardinality going to be alif naught square, so it is alif naught. Similarly, the cardinality of P2 is going to be alif naught cube, that is alif naught, and the cardinality of alif naught. Okay, so all the Pn have the cardinality alif naught, that is they are countable set, and you have the countable union. So by our previous logic, it is the set P is going to be countable, correct. Countable means denumerable. So this first option, that is the first option A, it is true option, so it is not going to be your correct one. Similarly, try for the B, C and D, these three questions. Try for all of this. Obviously the fourth one, it is just your common sense. Try, verify for B and C, and also put up your answer in the comment section. Fine. So thank you for watching, and in the next video I will provide few more questions along with their solution, and if you find anything doubtful, I will clarify in the next video. Fine. Thank you.